Good morning, everyone, or hello. My name is Nevyana, and I am professor at Sofia University, Faculty of Economics and Business Administration. Today, I would like to present our conceptual framework for understanding competence development in AI-supported and gamified learning environments within Industry 5.0 education. The central idea of the paper is relatively simple but important. Measuring learner activity is not the same as understanding learning. AI can tell us learners do. It can identify patterns, provide feedback, and personalize learning. However, we still need to understand how these activities become meaningful learning and eventually recognize competence. To address the problem, we propose the Interpretive Circulatory Competence Framework, or ICCF. In the next few minutes, I'll explain the problem that motivated the framework, its three dimensions, how they interact, and what the framework contributes to research on human-centered AI education. Let me begin with the problem. Artificial intelligence and learning analytics have significantly expanded our ability to collect and interpret educational data. We can track clicks, participation, responses, revisions, discussions, and many other forms of learner activity. Adaptive systems can use this information to personalize tasks and feedback. Gamification adds another layer, but encouraging participation through challenges, feedback points, badges, and other interactive mechanisms. But there is a fundamental limitation. A learner can be highly active without necessarily developing competence. For example, a student may complete many activities, interact frequently with an AI system, and obtain high engagement scores. But this does not automatically tell us whether the student has reflected on mistakes, improved their reasoning, or developed a transferable competence. Therefore, the key question is not simply how active is the learner. The more important question is how does learner activity become cognitive development and institutionally recognized competence. This is the starting point of this framework. When we examine the existing literature, we identified the conceptual fragmentation. Learning analytics primarily focuses on measuring learner behavior and in many cases predicting outcomes. Adaptive learning focuses on personalization, how the system can modify learning experiences according to learner needs. Gamification focuses mainly on participation, engagement, persistence, and motivation. And competence-based education focuses on assessment and recognition of learning outcomes. Each of these perspectives is valuable. The problem is that they are often examined separately. What is less clearly explained is the process connecting them. In other words, how does interaction generate meaningful evidence? How does that evidence lead to the cognitive adaptation? And finally, how does this learning become formally recognized as competence? This is the conceptual gap that ICCF is designed to address. The main contribution of the paper is the Interpretive Circulatory Competence Framework. The word circulatory is important. We do not see learning as a one-directional process in which data are collected and a final score is produced. Instead, we conceptualize learning as a continuous cycle. Learner interaction generates behavioral evidence. AI-supported analytics interpret this evidence and can provide adaptive feedback. The learner then reflects, corrects errors, revises solutions, and develops understanding. The resulting competence can be connected to curriculum objectives, assessment structures, and institutional recognition. And this recognition evidence can then influence future learning and adaptation. So, the framework creates a bridge between data, cognition, and institutional meaning. Importantly, AI does not replace human judgment in this model. AI provides analytical support, but educators and institutions remain responsible for interpreting and validating the evidence. The ICCF operationalizes this idea through three interconnected dimensions. The first is communicative intensity, or CI. This represents the interactional dimension, how learners participate, communicate, respond, collaborate, and engage with digital learning resources. The second is critical resilience, or CR. This represents the cognitive dimension. It concerns that happens after interaction, whether learners use feedback, correct mistakes, revise their solutions, and progressively improve their understanding. The third dimension is institutional integration, or II. This represents the organizational level. It asks whether learning evidence is aligned with curriculum objectives, assessment criteria, competence frameworks, and certification or recognition mechanisms. The important point is that these are not three independent indicators. They are connected. CI tells us about interactions. CR tells us whether interaction is transformed into learning, and II tells us whether that learning acquires educational and institutional value. There is another important element in the framework, the human-centered governance layer. This layer is deliberately not presented as a fourth dimension. Instead, it surrounds and governs the three dimensions. Why is it necessary? Because learning analytics involves sensitive learner data and increasingly sophisticated AI recommendations. If an AI system identifies a pattern of recommends a learning intervention, that recommendation should not automatically become an educational decision. Educators need to understand the evidence, evaluate its relevance, and consider the pedagogical context. Therefore, the governance layer incorporates transparency, explainability, privacy, ethical considerations, and human oversight. This is particularly important with Industry 5.0 perspective, where technology is expected to enhance human capabilities rather than replace human decision-making. So, in our framework, AI is powerful, but it remains a decision support mechanism. Let us now move from the conceptual level to its practical interpretation. Imagine a university course using a gamified digital learning environment. Students complete project-based activities. The platform records their participation, communication, task activity, errors, and revisions. At the first level, these data contribute to communicative intensity. The AI system can identify patterns and provide personalized feedback or recommendations. The learner uses the feedback to revise a solution, correct an error, or try a different approach. This process contributes to critical resilience. Finally, the evidence generated through these activities can be connected to portfolios, assessment criteria, curriculum objectives, or competence frameworks. This contributes to institutional integration, so the framework allows us to follow the entire trajectory, from learner activity through cognitive transformation to recognized competence. That is practical meaning of circulatory model. One of the useful implications of the framework is that it allows us to distinguish different learning trajectories. Consider the first scenario. A learner may have very high communicative intensity. They participate frequently, complete many tasks, and interact extensively with the platform. But if critical resilience is low, this may simply represent activity without sufficient cognitive transformation. In the second scenario, a learner may demonstrate strong critical resilience. They reflect, revise, and genuinely improve their understanding. However, if institutional integration is weak, this learning may remain disconnected from formal assessment and competence recognition. The third scenario is what the framework considers the desired trajectory, when interaction, cognitive adaptation, and institutional recognition reinforce each other. We have a more complete picture of competence development. This is why ICCF argues against optimizing a single metric such as engagement. The objective is not simply to maximize activity, it is to support a balanced competence formation process. Because the ICCF is a conceptual framework, the authors also conducted a preliminary expert-based assessment. 12 higher education instructors with experience in digital education, educational technologies, learning analytics, AI in education, and competence-based learning evaluated the framework. The overall mean score across the evaluation criteria was 4.42 out of 5, indicating strong engagement. The highest rated criterion was the alignment of the framework with human-centered AI and Industry 5.0 principles, with a mean of 4.58. Experts also positively evaluated the integration of behavioral interaction, cognitive adaptation, and institutional recognition. The reliability of the questionnaire was satisfactory, with a Cronbach alpha of 0.86. However, an important methodological point must be emphasized. These results do not validate the causal relationship proposed by the framework. They provide preliminary evidence regarding conceptual clarity, relevance, and perceived applicability. Empirical validation remains a task for future research. Let me conclude with the main contribution of the paper. The ICCF does not propose another predictive algorithm, and it does not attempt to replace existing learning analytics, adaptive learning, or pedagogical theories. Its contribution is conceptual. It provides an interpretive layer that connects three levels that are often considered separately: learner behavior, cognitive transformation, and institutional recognition. In this sense, the framework proposes a shift from activity-centered analytics toward competence-centered interpretation. The central message is that educational AI should not stop at measuring what learners do. We need to understand what happens between activity and competence. Interaction generates evidence. Evidence can stimulate reflection and adaptation, and developed competence needs to acquire meaning within the educational and institutional structures. At the same time, the process must remain human-centered, transparent, explainable, and accountable. The ICCF therefore provides a conceptual foundation for future empirical research using longitudinal learning analytics, experimental implementation, and cross-institutional comparisons. Ultimately, the question is not simply whether AI can collect more educational data. The more important question is whether we can use those data to understand and support meaningful human competence development. Thank you very much for your attention. It's time for question and answers, and have a very nice day. Thank you very much, and bye-bye.